Okay, let's talk about technical drawing ultimate. So, why do you need to absolutely master technical drawing? Well, it's the logical part of architectural drawing, so it's the problem-solving part. And it covers around 50% of all the architectural drawing out there. Okay, so it's architectural drawing isn't just about you sketching, but it's actually about producing these wonderful technical drawings, triple projections, axonometrics, sections, plans, etc. So obviously learning this stuff is going to get you better at architecture. So let's look at the correct mindset you could have towards technical drawing. It does count for 50% of the drawings out there, but that doesn't mean it's stuck. It's the same as freehand drawing. It always has kind of like a creative side, although it's more towards the logical. Obviously, technical drawing doesn't exist in real life, so everything you see around you is in perspective. The 2D and 3D technical drawings are completely abstract. Right, so let's think about that for a second. So because it is 100% abstract, then obviously it's going to imply that you need a certain type of logically abstract mind to make it work. Okay, let's go for the left brain and the right brain comparison, right? Because, obviously, huge generalization, but your brain is split into the logical and the less logical, slightly more intuitive part, right? You could say that the left hemisphere is the logical problem-solving part, the right hemisphere is the artistic, intuitive part, right? Logical, linear thinking, abstract, random, creative thinking. Okay, so obviously we need to balance the two, with technical being slightly more towards the left brain. Okay, right, so let's talk about graphics now. Okay, we're just going through this rapid fire mode, and then we will obviously go for an exercise. You need to have the three lines in your drawing, right? There's three types of lines. You can see them here, like construction lines, the ones you use to basically construct and draw the specific technical drawing. You don't want to just end up with a image. You want to see the construction behind the specific axonometric or 2D technical drawing. You also have contour lines, which basically are meant to show the lines that you see. Okay, so you can see them on the top right hand side. These contour lines make your volume kind of take shape. Okay, then obviously you've got thick lines, which are going to be used for cast shadows, for sections, right? You can see them for the cast shadows there, bottom left hand side, and obviously you've got the dashed lines as a bonus. Okay, they're optional. You can use them to thicken some of the construction lines. Okay, but if you have all these four types of lines, then you get really good graphics. Right, that's the end result. Right, so let's have like a short, really quick warning about technical drawing. It is going to come across as if you don't get technical drawing, if you don't understand it, so if you look at this and it's just alien to you, you might think that you are lacking an intelligence point, right? Yeah, you might feel that you're not smart enough to get good at this, okay? It's kind of true, but it isn't, okay? You're not smart enough now because it's really not your fault, because you don't know the things that you need to learn to create stuff like this. We will go through an exercise, and you obviously learn this stuff, and then you'll be able to slowly but surely get there, okay? The more technical drawing you do, the truth is, it really trains your mind, and the better and smarter you will get, and a better problem solver you'll become. Okay, so the fundamental principle behind technical drawing is geometrical construction. So you probably don't know how to draw something, okay? That's fine, you geometrically construct it. That's the gist of the thing. Okay, so basically you start with the four types of lines, with the construction lines, and you slowly but surely construct the volume. And this needs to become kind of a mental habit, Okay, you need to get used to approaching all the technical drawings you come across with this thinking of geometrical construction. Next up, you've got descriptive geometry, which is interesting. Basically 95% of descriptive geometry is always the same, so it's the drawing part, okay? But the other 5% is the scary part where you need to problem solve. For instance, we've got a cube on a spatial diagonal on the left hand side. You know, if you've got a bit of experience in technical drawing, you know this is a fairly standard drawing, so it's nothing special. But once you add that sphere on the inside and you extract that section, how is the end volume going to look like? That is where you will struggle, okay? The section on the right, where you've got a weird ellipse, okay, that is where you will struggle. And obviously you can never say that descriptive geometry is perfect, or you know it, or it's done, you understand it, it's final. No, it's always going to come up with something that's going to shock you, okay? And obviously by separating the 95 and the 5% right, elements, you will get a very good level of clarity in your approach to drawing. Okay, spatial vision, the next topic. You will be able to see volumes in 3D, which is very good. It's really going to help you, and it is going to fry your brain. There is absolutely no way around this. You basically need to upgrade your brain. This is the part that makes you smarter. Okay, freehand drawing is going to help, but technical drawing is 100% about spatial 3D vision. Okay, let's talk about the 7 categories of technical drawing. So, number 1, simple volumes, weird volumes. Okay, so basically you'll just draw stuff that looks weird. Okay, different planes, different elements that sorry, leave cast shadows, or they don't, etc, etc. Okay, you just need to get used to drawing them. There's no problem solving involved. It's just the slowly but steadily you will basically progress and take things into the 95% category, right? So you will get used to basically putting the standard approach of drawing on autopilot. So here you've got just simple volumes, and then the 5%, which is a bit more complicated, is the cast shadow. Full stop. That's it, right? The next exercise, it's going to, you know, the cast shadow is going to be on autopilot, and something else is going to come up. Geometrical spaces. This is mostly structured around basically assignments that talk about spheres. Okay, how do you sort out tangencies? Okay, so what is the exact position that you put an object in technical drawing where it 100% correctly matches a condition of tangency? Tangency means, it's just a fancy way of saying that the volumes, you know, touch in a specific point, right? So you see a sphere which is tangent to 3 tetrahedra, and in theory these tetrahedra stay in perfect balance, right? Again, it's going to shift. You've got many assignments where, you know, obviously you need to rotate it, and you use these arches and all sorts of geometrical constructions to help you find these tangencies. Number 3, volume intersections. So these intersections are like simple volumes that intersect, and you need to see how they cut and form that intersection, which is again very interesting. Okay, obviously you don't take these types of drawings at face value. You see that they have principles behind them, like multiple axes of symmetry. You see that there's patterns. Okay, there are a couple of patterns even in the drawing you see here. It's obviously both volumes have axes of symmetry, and they're kind of easy to basically sort out. Then you've got like the funky and weird intersections, which just melt your brain when you see them. okay, but they develop spatial vision like nothing else. Constructive shadows, these are going to be interesting for weird volumes. When you're starting off, you've got just a couple of patterns, okay, of constructive shadows. But then as you keep moving on with your exercises, with your drawing prowess, you keep seeing more and more of these basically patterns. These simple ones just go on autopilot, they're standard, but you go for the weird ones which aren't predictable and which you need to basically problem solve on the spot, so to speak. Again, spatial vision, problem solving, very important stuff. And we are going to go for constructive shadows for 2D volumes as well, right? So basically a frontal view with cast shadows, which is different than the axonometric approach. But I'll just leave that for now, because it's just going to distract you if we go into too much details, right? But remember, you've got constructive shadows in axonometric / 3D and in 2D as well. Roofing. This is a very interesting exercise. This is something that I see all the time, kind of messed up by most students. The roofing exercises just have a number of variations, and obviously, again, the same principle applies. You learn certain things and then you put them on autopilot. And there are a couple of patterns of roofing that you just learn, and then there's the weird ones, which we are obviously going to tackle in a future assignment, and which are very complex. Okay, they just got weird stuff about them. Planar changes, these are mostly these are about 3D vision again, but they are probably the most challenging, because they just challenge you to basically reimagine the way you see a simple volume. So you see, you go like a pentagonal pyramid, and you flip it on one side, and that is a planar change, right? You take it from one position and you put it into a specific position where one of the planes becomes a horizontal plane, one of the sides of the pyramid becomes a horizontal plane, and then you basically create the shape itself. Again, you can draw this in axonometric with cast shadows. It's going to make for a very interesting exercise. And number 7, building floor plans and sections. These have a scale attached to them. Okay, 1 to 100, 1 to 50, 1 to 20, etc., right? But again, this is interesting, but you don't want to go there, because it's plans are very much linked to basically you understanding and knowing a bit of design. Okay, this is the last thing you need to learn. You need to explore the other 6 categories, and then you get to this. Right, so 2D and 3D technical drawing. Obviously, they both are important, equally as important. You need to be able to jump from 2D technical drawing to 3D. So obviously you got a planar frontal and side views, and a side view, and all these views work together. Okay, so they describe the same volume, and obviously you need to understand them before you can move on with your work. Okay, so 3D technical drawing, the same volume described previously, but in 3D. And this is done by the axonometric. Basically, the axonometric is a way of describing a volume in a way that it's how can I say this? It's just basically projected in 3D with in perspective. If parallel lines in perspective go to the same perspective point in axonometric, they are parallel to the specific axes from the coordinate system. Okay, again, it's an abstract drawing, and again, both are abstract drawings, but you need to understand them. The only way to understand them is by drawing them. So let's go for 2 exercises, which I want to compound in one exercise. We will draw a cube on a spatial diagonal, and then go for it in an axonometric. Okay, let's go. Right, so let's start with the cube. Measure 4 centimeters here, and I should go and have a 45-degree triangle. Don't have one.
get one, right. Right, now we need to rotate this at 45 degrees, let's go. Vertical here, let's thicken the important lines. The edges, right, one here, one here. Always, always thicken all the parallel lines in one go, so you make things easier for you. And now we need to go to the third position. Might need a bit more space for this. Right, draw a vertical line. Look at this canvas, it's a mess. I'm going to grab this as a radius for an arch. Boom. Center here. Right. Circle here. Then grab the length. And now we need to draw, if you're looking like this, you'll see this edge and this face. So we'll have this, this. Obviously it's overlapping a bit, so sorry about that. Okay, here, here, here. This is the faces that we see, so they're like in contour drawing. We got our contour lines. And then the other faces are dashed. Nice one. Now we need to draw the side view. Going to look this way. So we're going to see this face first. Right, so that's visible. Contour line. The other ones are dashed. And as always, we need to construct the lines that we don't see, right? Which are these lines here. Right? You need to give this a moment so you see it in 3D. But our cube can actually have two different positions on a diagonal. It's going to look a lot different, deformed in a different way, right? Because as you remember in axonometrics, they're not, you know, these cubes aren't exactly how you plan them to be. Probably it's going to look something more like this, with this face here, right? Not as small, but more like visible, you know, like bulky, and these other faces being like smaller. Right, so let's get to this. Right, all edges on, all distances on the same sheet of paper. So already this is looking a bit different. Why normal people won't understand this? Because normal people don't have any 3D vision. They can't see what's going on here, that this rectangle is the same, it's just flipped. Right, so now let's draw those faces. This is dotted, because you can't really see it. Right, so this is our cube. Next. Now let's do the cast shadow. As always, 1, 2, 3, 4, 5, 6, 7, 8. It's 1. So this is the third point. Right. It's going to look similar to some sort of rectangle. Double check if it's correct. Check if these edges are parallel and if these edges are parallel as well. Right, let's go to the next bit. So 5 is here, here. 6 is here. And 8 is here. Well, connect these two shadows and do the outline. You'll use a pencil. Right, so this is the cast shadow. So we got two options for our cube. You need to understand both of them, right? Boom.
Okay, so how can you get good at technical drawing? Well, there's just one way. To basically master descriptive geometry. So this can be seen as the really difficult part of learning technical, because it's not about graphics. It's 100% about you problem solving, and it's as left brain as it can get, because basically you need to problem solve. You need to figure out how to draw certain things that don't make sense. And again, with all the practice you could get in descriptive geometry, there's always going to be stuff that just doesn't make sense, and stuff that you can't see in 3D yet, right? Until you make the upgrade in your mind. And of course, to get good at technical, you need to manage brain fry. And obviously you will get brain fried from descriptive geometry, from technical drawing, from everything. It's because neurogenesis kicks in and you start making new mental connections, and obviously this is going to basically be very taxing on your nervous system, but that's fine. Again, we know this is going to happen, it will happen, so it's fine, okay? And obviously sleep is the only way that you can heal yourself from brain fry. Okay, so let's talk about what you could do if you're an extra artistic type. So you're very artistic, right? You're basically the type of person that's more of an artist than a technical person. Well, got bad news for you. Technical drawing is always going to be a struggle, and yeah, if you're an emotional artist type, that gets even worse, but that's fine. It's fine because you can basically build up your skill set, and you will get massive wins from this. You will study up on technical, and that's going to improve your freehand drawing as well, because a solid understanding of technical is going to balance out your artistic tendencies. It's going to make you more grounded in your ideas. You'll see that your ideas will become just more quality. It's going to stop your imagination from going crazy, and yeah, obviously it's going to make you a bit more balanced. Again, the most, I could say the most important thing that I've seen, creatives or artistic types, fail at, is that they try to interpret technical drawing, which is kind of missing the point. You're not meant to interpret it, to make it artistic in any way. It's not an open-ended thing with various interpretations. It's got a solid approach where you need to solve it. Okay, so there's not many ways to make this volumetric intersection. There's just one correct way, and you need to focus on that and understand it, okay? So, okay, I recommend you start taking notes right now of all the stuff we talked about, because it's all about mental discipline. And then as an artistic type, there's chances that, you don't have that mental discipline, okay? You probably haven't even sketched any of the stuff we talked about, right? Which is very bad. Let's go for it. Okay, so what to do if you're an extra logical type? Okay, you got the other 50% of drawing left. So if you're logical, you're good at this stuff. It comes, first nature. But you need to have the creative part as well if you want to get good at architectural drawing. Never be overconfident with technical drawing. I've seen students make this mistake. They think they get it, they have it sorted. That's almost never the case. There's always going to be something that comes up, okay? And if you're technical, as in, maybe you've got a background in engineering, never fall for the trap of thinking that this stuff isn't going to imply at least a certain amount of architectural creativity, okay? Because although it is logical, it does have that architectural thing to it, okay? And the better you get at technical, obviously the better you get at the functionalist part of architecture, which is all good. Let's not forget, at the end of the day, it's all about mixing both the creative and the functional parts. So let's talk about how to mix technical with freehand. okay? Because it's obviously we discussed all these interesting topics, but technical can work as a valid artistic type of drawing. It does look especially architectural or especially good design-wise. But the more you add extra graphics to technical drawing, the more the focus shifts from something artistic to from something technical to something more artistic. So it starts becoming a presentation drawing, like a perspective, rather than something that's technical, like descriptive geometry. So how could you progress in all this stuff, you see, because we talked about so many things? Well, you can start off with simple volumes, triple projection, axonometric, okay? You've got the 5-day intensive where I share, I think at least half of the lessons, 2 or 3 lessons are about technical drawing. So you go through the simple volumes in triple projection and axonometric. You need to understand cast shadows. They will be extremely important for freehand drawing, for perspective. And you need to slowly but surely ease in to descriptive geometry. And you get used to simple technical drawing exercises, and then obviously you can shift towards the more complex ones. So a short recap: the correct mindset towards technical drawing, we talked about that. The left brain and right brain, and how technical works with both, we talked about that. The graphics that you could use to get good at technical. Geometrical construction as a principle. Descriptive geometry and how it builds up spatial and 3D vision. The 7 categories of technical drawing that you need to master in order to be good at technical. We talked about a couple of technical drawing exercises. I did the cube on a spatial diagonal. Now we know how to get good at technical drawing and what to do if you're an extra artistic and logical type, and then how you can mix technical with freehand. Because mixing technical with freehand is going to get you an edge, a creative edge. Cool, so if you like this video, don't forget to comment, rate, and subscribe. And if you've got any questions, then obviously message me in the comments box below. And obviously you can go for the 5-day intensive, where I've got a couple of lessons on technical drawing, and you can also check out a couple of free lessons from my course on technical drawing mastery. This is Michael N. You take care. Draw nicely.